Welcome to The Explainer. Today, we're taking a close look at a piece of tech that its creators are confidently hailing as the everything computer. And honestly, considering it took nearly 4 years of intense, behind-the-scenes development to bring it to life, it's easy to see why. We are, of course, talking about the Raspberry Pi 5. Now, if you've been following the single-board computer space for a while, you know that each generation brings a few nice tweaks. But this latest iteration represents a massive structural and performance leap forward.
So here's the ultimate question, right? Can a computer the exact size of a credit card actually replace your daily desktop? With the absolute insane power jump we're seeing in this new model, we're talking dual 4K 60Hz display outputs and some truly state-of-the-art camera support, the answer is leaning way closer to yes than ever before. Is it finally time to ditch the traditional clunky PC? Let's find out.
Here is our roadmap for today. Think of it as the engine, the payload, and the fuel. Section 1, meet the everything computer. Section 2, the RP1 Silicon Advantage. Then we get to the payload. Section 3, mastering the camera setup. And Section 4, epic camera use cases. And finally, the fuel. Section 5, powering the Pi 5.
All right, Section 1, meet the everything computer. Let's officially meet the Raspberry Pi 5.
Okay, let's dive into this, because honestly, the numbers here are just staggering. The Raspberry Pi 5 features a Broadcom 64-bit quad-core ARM Cortex-A66 processor, and it is running at a blistering 2.4 GHz. So what does that actually mean for you in practical terms? Well, it delivers a massive 2 to 3 times jump in CPU performance compared to the older Pi 4. Pair that with an 800 MHz VideoCore V7 GPU, and you are getting a wildly smooth desktop experience. Seriously, it's so fast you might literally need to bolt it down just to keep it from taking flight.
Plus, you've got a ton of flexibility to tailor this engine exactly to your needs. It starts at a super accessible $45 for the 1GB model, which is absolutely perfect for budget DIYers. But if you're a heavy-duty maker and you need serious overhead for a massive project, you can scale this whole shebang all the way up to a 16GB model for $305. It perfectly bridges the gap between simple weekend tinkering and real-deal industrial applications. Moving right along to Section 2, the RP1 Silicon Advantage. This is all about what's built entirely in-house.
Now, what's really interesting about this is that prominent little chip right in the center with the Raspberry Pi logo on it. For the very first time ever, this is a full-size Raspberry Pi computer using silicon built entirely in-house. It's called the RP1 Southbridge chip. It essentially provides the bulk of the I/O capabilities for the Pi 5, and it represents a complete step change in peripheral performance.
Let me just play tech translator for a second here, because these dense specs are incredibly exciting. Thanks to that brand new RP1 chip, aggregate USB bandwidth is more than doubled. That means your external drives are going to transfer data significantly faster. And you know those old dedicated camera and display interfaces? Well, they're gone. They've been replaced by a pair of 4-lane MIPI transceivers. This triples your total bandwidth, meaning you can now run any combination of up to 2 cameras or displays simultaneously, no problem. Plus, we're seeing doubled peak SD card performance and, drumroll please, a single-lane PCIe 2.0 interface for incredibly fast high-bandwidth peripherals, a real game changer.
All right, payload time. Section 3, mastering the camera setup. Let's get into connecting Camera Mod 3.
First up, let's talk about the physical hardware. The Pi 5 actually uses a 22-pin CSI cable now, unlike the 15-pin you might be used to on older models, so definitely make sure you have the right ribbon on hand. The process is pretty precise but simple. First, always power off the board. Second, gently lift the black latch on the port. Seriously, don't yank it unless you just really enjoy ordering replacement parts. Third, slide that 22-pin ribbon right in with the contacts facing the correct way until it naturally stops. And fourth, press the latch down evenly to lock it in place without any wobble. Oh, and a quick pro tip for you. Give the cable a nice, smooth curve. Sharp kinks in the ribbon are literally the #1 cause of frustrating camera disconnects.
Okay, so once you're perfectly plugged in and your OS is fully updated, you'll obviously want to test it. Here is a brilliant insider cheat sheet. Open up your terminal and run this. RPCam hello -T 8S-autofocus mode continuous. What does this do? It pops open a live preview for exactly 8 seconds, and because you've set it to continuous, you will literally see the lens physically snap into sharp focus as you move objects closer and further away from it. It just completely takes all the guesswork out of your camera rig.
Let's see how this builds into real projects. Imagine you're a maker trying to shoot a tiny, densely packed circuit board to document a microscopic little solder joint. Standard focus? Yeah, that just won't cut it. You'd normally be pulling your hair out trying to adjust the lens manually. Instead, you just drop this specific command, RPIM still T2S autofocus range macro. That macro flag nudges the focus specifically for tiny components positioned right up against the lens. It totally saves the day and gives you a crystal clear product shot.
Which brings us to Section 4, Epic Camera Use Cases. What will you build?
The possibilities here are literally endless. You could set up Octoprint to monitor your 3D printer, using that sharp autofocus to capture super satisfying time lapses of your prints. Or you could build a motion-triggered bird feeder or wildlife camera using a night vision module. How about a DIY teleprompter with a silent focus facecam so you maintain perfect eye contact during your recordings? You can capture brilliant home lab macro shots of tiny components. Or, hey, leverage that massive Pi 5 horsepower boost we talked about earlier to run real-time object detection for smart home alerts. The hardware has finally caught up to our imaginations.
Finally, the fuel. Section 5, Powering the Pi 5. Let's understand USB power delivery.
Okay, this right here is the absolute golden rule of Raspberry Pi 5 power. 5 volts, 5 amps. The Pi 5 requires a highly stable 5-volt rail to function properly. But to unlock the absolute maximum 25 watts of power, which is what allows you to run power-hungry hats and heavy USB peripherals, the system actively looks for a power supply that specifically advertises a 5V 5A capability.
So the crucial point is this: what actually happens if you just use a random old phone charger you found in a drawer? Well, your old charger will technically turn the board on, but your Pi would essentially be running in survival mode. If a 5V 5A supply is not actively detected during the USB PD handshake, the Pi 5 immediately goes into a defensive mode. The total power available to your USB ports drops dramatically, from a robust 1.6 amps down to a measly 600 milliamps. USB booting even gets disabled by default. If you have high current devices plugged in, like an SSD or a hard drive, they are simply going to choke and fail to operate correctly.
And this brilliantly illustrates the safest, most headache-free solution, the official Raspberry Pi 27-watt and 45-watt USB-C power supplies. These are specifically designed and guaranteed to negotiate that optional 5V 5A power profile correctly every single time. They use thick, non-detachable cables to minimize any power loss, ensuring your Pi has the stable, clean fuel it needs to run those intensive camera and dual display setups without even breaking a sweat.
But wait, what if you have a custom bench power supply? You know, one that definitely pushes a full 5 amps, but it just doesn't use the specific USB PD negotiation protocol. Like we said, the Pi would normally just default to low power, but there is actually a secret developer trick to bypass this entirely. By going into the bootloader's EEPROM settings and typing in PSU_max_current equals 5000, you are explicitly instructing the firmware to skip the USB PD negotiation process and just force the full 1.6 amps to the USB ports anyway. It's an amazing little bypass, but really only for advanced makers who know exactly what their hardware can handle safely. From the massive, staggering jump in CPU speed to that revolutionary in-house RP1 chip, all the way down to advanced camera logic and strict power delivery, the Raspberry Pi 5 is just a remarkably capable machine. It truly, genuinely earns the title of the everything computer. So the only question left for you is, you have the power? What will you build next? Thanks so much for joining me on this explainer, and I'll catch you next time.